Ladies and gentlemen, please welcome to the stage Dave Russell.
Thanks to the organisers for an incredibly cool venue. I love the idea of a conference in a cinema. It's a great idea. So this is interactive, so please take a look at slido.com and hashtag Big Data 2018. This is room 6. You all found your way here, so well done. And you'll be able to ask questions in there. We'll have time for questions at the end. And actually, the first question from in the room gets a pen and a notebook. And the first 3 people to ask all get a notebook. After that, I'm afraid it's only stickers. So think of good questions, and let's get into it. So actually, before we go into this, let's do something a bit different. Let's go and let's show you some of the output of what this is all about. Because usually you have to listen to a whole bunch of waffle before you actually find out what it is you're here to see. This is the output. This is the result of using Apache Metron. In this particular case, this is authentication data provided by Los Alamos National Labs, where they had something called a red team exercise. They were trying to find someone that had been tasked with breaking into their network, breaking into their environment. And you can see the data that's been run through Metron and enriched and profiled and all this good stuff that we'll be talking about as we go through this follows a pretty normal pattern. You can see there's blue squares, so those are departmental servers, and you can see that in the most cases those black dots, those are users connecting to those servers, usually a user connecting to 1, maybe 2 servers. And you can see this kind of flower pattern is a fairly normal pattern of access. I'm just going to skip through this a little bit. You'll also see, however, that there are some anomalies. There's people sort of connecting to servers that are very disconnected from others. You've also got, if we skip through to this, you've got people accessing a server known as TGT. So that's the Kerberos ticket server. You can see the black dots around it are really small. That's because you get your Kerberos ticket and then you don't need to visit that server again until your ticket expires. So that makes perfect sense. But what is fairly unusual in this whole picture, and hopefully some of you may have picked out, is, if we skip forward, this cluster right here. So you've got one black dot in the center, one user, accessing a whole bunch of servers. Anybody willing to guess if that's the person attempting to break in? Well, it was. And I say that was detected using data that Los Alamos National Labs released and anonymized. So you can actually download and play with that yourself. Anyway, so that's the end result. So how did we get there? And more importantly, how can you do this? Because the title of the talk is Apache Metron in the Real World. So just a little bit about me first. Who am I? Who's talking to you here? So my name is Dave Russell. I work for Hortonworks, one of the leaders in the big data world. I spend a lot of my time traveling, talking to customers, coming up with solution designs. I spend a lot of my time in airports. And very occasionally, when I'm not traveling and visiting customers and other exciting people and talking at conferences like this, you'll find me in the wilderness of England over in Herefordshire. I also am one of the founding co-hosts of the Roaring Elephant podcast. So if you like listening to podcasts while stuck in traffic or on your commute to and from work, maybe this is something of interest to you. We've been running for about just over 3 years now, so there's a nice back catalogue of stuff for you to start listening to. So let's try and answer the first question. Why Apache Metron? Well, really, cybersecurity and big data are a perfect match. There's no shortage of data in the cybersecurity world. In fact, it's exactly the opposite. There's almost too much data, and it's all in individual silos. And for anyone that's been doing big data for a while, like myself, this is sounding very, very similar to all of the kinds of things that big data was actually designed to resolve in the first place. So you've got all of these different data silos that you can't correlate anything in between. You've got issues where you actually have to aggregate a lot of that data very early on because you can't retain it for long enough in the granular enough state. So, sounds like a big data problem to me. The other interesting thing around this is you can see here it actually takes an average of 9 months before the majority of breaches are actually detected. I spend a lot of my time talking to organizations who have existing solutions, existing siloed solutions. Usually, the average retention period is about 6 months. So that means that by the time someone actually finds out they've been compromised, the data that would tell them what happened has already expired off those systems, or been aggregated or compressed or moved to offline systems, so it really blunts their ability to respond in time. The other interesting thing about this is that in the majority of cases, most organizations actually don't find out themselves that they've been breached. Someone else tells them, which I think is a particularly scary statistic. So that can be a government agency, or it can just be someone saying, hey, did you realize your entire customer list was just posted online on the dark web? Here's some other examples of breaches and the actual duration before they were properly detected. So Police One is a US system used by a variety of police forces and federal agencies containing home addresses, work locations, phone numbers of law enforcement officials, including FBI and other three-letter agencies. That was breached and wasn't detected for 28 months. The somewhat famous now Yahoo breach, 35 months before it was detected. You could argue that the whole Facebook Cambridge Analytica wasn't a breach in the traditional sense, it was more of a breach of trust. But you could also argue that they really should have known what was happening with their data, and they clearly did not. There's a guy named Ian Levy who's technical director of the National Cybersecurity Centre in the UK, and this is an offshoot of GCHQ. And he's talking here about the fact that he believes that there will be a Category 1 cybersecurity incident. Now, what he's saying here is that in the 11 months when he made this quote that the organisation had been up and running, they had detected what they call 500 level 3 incidents. So that's where a single company is affected and severely impacted. He also detected, and this is globally, 30 Category 2 events. So those are things like WannaCry, where multiple organizations were affected. It's a fact that the majority of these breaches are happening now in seconds and minutes. It's not something that happens in hours or days. Spear phishing attacks used to be something that were quite laughable. Emails that quite clearly were nothing at all to do with the organization they claim to be. In the majority of cases, they are getting very, very sophisticated, and it is sometimes incredibly difficult to tell exactly whether or not this email is real or a phishing attack. And this is just a summary of some of the organizations that publicly said that they had been severely affected by WannaCry. This was just a snapshot of the page that is, I think, currently on Wikipedia. So at that point in time. Similarly, organizations like Under Armour, 150 million customer records released online. 340 million from Exactis. So that's why Apache Metron. Let's see if we can stop some of this bleed. What does it actually look like? Well, it always starts with the data. And in the majority of cases, we're talking about streaming data. This is actually a few lines of data from that Los Alamos National Labs. This is authentication data, anonymized in this case. So things that would normally be IP addresses and users are replaced. But otherwise, it pretty much looks like this. What does it look when it's run through? Well, this is an example of the alerts dashboard. And what you can see here is after the events have gone through Metron, they're given a score, and this is based on all of the other components that Metron has allocated to those individual events on their way through. You also get a reason why that score has been set. So you can see for this one, it says the distinct number of machines that user 22 attempted to log into, 2, is more than 5 standard deviations, 0.29 from the median. So this is using relatively simple statistical methods, but it is doing this at full real-time speed. And we can talk about some of the scale that this is operating a bit later. So what is Apache Metron? In my opinion, it is one of the coolest ways to use lots and lots of the animals in the zoo, as we say. It is built on core, fundamental, and very much proven technologies in the big data world. Everything from Solr, NiFi, Kafka, Spark, Ranger, HBase, all those core components are heavily utilized within the Apache Metron framework. So Apache Metron really is an architecture for dealing with streaming real-time cybersecurity data. Now, this screen is actually large enough I can just use this one, but not normally used to screens this big, so let's use the version that magnifies instead. So it all starts with the data. It always starts with the data. The data is the most important thing in all big data, because without the data, nothing else exists. And in our case, we're looking at a variety of telemetry data sources that are coming in. There's the standard security endpoint devices, FireEyes, Palo Altos, Blue Coat proxies, all those kind of things. You've then got data coming in from machine-generated logs, AD authentication, application servers, web servers, VPNs, firewalls, all that kind of good stuff. You can also bring in intrusion detection system data, and we can bring in threat intelligence feeds used for enrichment further on down the line. We can also bring in raw PCAP data and NetFlow data, both of which are incredibly rich sources, but very, very large. Again, perfect for a big data platform. We can actually use PCAP data a number of different ways. We can push it through something called BRO, which extracts out and gives us deep packet inspection information, or we can use it as a forensic data source later. So you can retain a rolling chunk of PCAP data from core important networks, so that if there is a compromise, you can actually go down to the packet level to identify exactly what happened, which sometimes is even more detailed than you'll get from all of these different standard log sources. So when we're bringing this data in, the majority of the log-based sources will bring in through NiFi. Think of NiFi as a graphical data pipelining tool. Deals with drag and drop creation of these pipelines, and not just drag and drop and then press a button and it creates some code and maybe the code works or maybe it doesn't, but actually drag and drop, and as you connect the points, the data immediately starts flowing. Very clever stuff. For things like the PCAP data and the NetFlow data, that's just too big, too chunky to push through something like NiFi. So we've got custom C-based probes for bringing in that data, and we use things like Intel's DPDK toolkit to bring that raw. We can bring in 10 gig feeds straight off the network very easily. And obviously we can also use NiFi to enrich the real-time data with some of that additional threat intel stuff. So the next phase is really the core of the Metron application. Now Metron plugs into a variety of different technologies, but it all starts with bringing it into Kafka. And then from that point on, we parse the data out. We parse it into a flexible JSON structure. We keep it very light in terms of things like schema, because we want to be able to expand the data as it flows through. Once we've parsed the events, we take them through the enrichment phase. Now the enrichment phase is really about adding a lot of that context into each and every single event that flows through. So the reason that context is important is, in this case, if you think about a security analyst looking at a screen, looking at an alert, often they'll do this thing called swivel chairing or swivel screening, where they got an alert and they want to know, is this real? Okay, so I now need to go and do some sort of internal lookup to find out, what asset this actually is. Is it the CFO's laptop, or is it the public access workstation in the lobby? One of those is significantly more important than the other. Where is this coming from? Is this coming from a user we know or anonymous user? Is this coming from within our organization or externally? Which VPN endpoint are they connecting to? Is this the normal VPN endpoint they connect to? All those kind of things. The idea of enriching this data is to make sure that they don't need to do any of that. When they get the alert, all of that context is already built into the alert. So take a blue coat web proxy event. It streams through. Maybe it's an authenticated proxy, so we've got a user ID. We can authenticate that against Active Directory tree information. That allows us to add things like the actual user's real name, their level in the organization, who their manager is, things like that. We can also enrich it against an asset database. That gives us more information about the piece of hardware or the device itself. Where is it physically located? Is it a mobile device? Is it a static device? Is it a server? All those kind of things. So on from enrichment into threat intel. So here is where we can use multiple threat intel sources. Some public sources, some sources that organizations develop themselves internally. And it's all about, again, adding further context to each and every event. Next step is the profiler. Now, for me, the profiler is the one piece of Metron. If you remember none of the rest of this entire talk, remember the piece about the profiler. The profiler delivers the ability to do real-time analytics on events as they're flowing through. So let's jump into the profiler just quickly here. You can see the profiler here is looking at 3 different data sources. One of them is very chatty, so maybe that's authentication data. One slightly less so, so maybe that's the DHCP data. And then one less so again, so maybe that's web proxy data. But the profiler can see all data flows that are flowing through the system at any one time. And so you can build profiles across multiple different flows. Now, windowing analytics is nothing new. Windowed analytics has been around for a long time. Why do I think that the profiler is so magical and so special? Well, usually the way that windowed analytics works is you have data flowing through, data flows through, and you put it all in memory until you've got it all stored up, until your window closes, or your sliding window, or tumbling window, or whatever it might be. Then you do some analysis on that data, and you output some statistics, and then you move on to the next. And that works just fine until you start dealing with the scale of data that we're now seeing in cybersecurity. We're talking about not just tens or hundreds or thousands of events per second. We're talking at millions of events per second. Some of them relatively chunky in size as well. Thing about Windows logs is they always contain a lot of cruft in them. But that sort of scale is something that we can handle with the profiler. So the reason that we can handle it is actually because we use these approximated data sketches. So you can determine the level of accuracy you want those data sketches to complete. And the nice thing about these data sketches is they are of a fixed size, regardless of whether you put 1 event, 10 events, or 1 million events through them. Now this is incredibly useful because this means that you can actually store very granular profile information in a very efficient way. So to give you an idea of what I mean by an efficient way, if you're storing this profile data for about 2 years, so you've got 50 different profiles and you're windowing every 5 minutes, then you're probably looking at maybe 10,000 users. You're only actually consuming about 3 servers full of HBase, or about 70 terabytes. So This is a great way to store that incredibly granular information. Now, what do I mean when I say a profile? So a profile can be something very simple, like if we take logins and failed authentication attempts. So a profile is created for each and every single device or instance on the platform. And what that means is that every user has their own profile created. I usually get my password right first or second time. There's a colleague of mine that furiously types and regularly gets his password wrong 5 or 6 times before getting it right. The traditional cybersecurity approach is set a threshold level of you can get it wrong 10 times and then we lock your account. But of course attackers work out what those thresholds are. Okay, we can try 9 times, leave 24 hours, try again. And do that over a number of accounts, a number of systems. Eventually people get in. So, but the profiler would detect that going on. It would detect my account being mined because I usually get mine right first or second time. So someone trying 9 times and resetting, that would be several standard deviations different from my ordinary profile. Similarly, if someone was to compromise my colleague's account, usually that then gets scripted. And usually that means that it's right first time every time. Now, given he never gets his password right first time, that again would be a massive change in his profile. So something the profiler would say this is drastically different to his normal utilization. And this is created for every single user in an incredibly efficient way. Think of another profile that we commonly see is inbound versus outbound networking. So think about something like ransomware. When a machine is compromised by some sort of ransomware or malware, you see the networking profile drastically shift. You can also add things like how many machines is a device talking to. Again, a malware attack or ransomware attack drastically changes that, and you can very quickly see something changing several orders of magnitude in terms of the number of systems it's talking to, the range of systems it's talking to, the number of people are accessing it, and so on. You can do this for anything, disk I/O, anything you like. And the profiler is also smart enough to understand how things change over the course of time. So, that's the profiler. Next step is alert triage. And really this is where you start to add some of the sort of the reasoning behind it. So this is where you've got fully enriched data at this point, and you can start to talk about, well, is this the CFO's laptop or is this the public access device in the lobby? You know, if someone's visited a phishing site in the public access machine in the lobby, sure, we'll get to that when we get to it. If it's the CFO's laptop being accessed from a VPN endpoint that he doesn't usually use by a user that doesn't usually visit that machine, that's probably something they need to care about immediately. After alert triage, indexing and writing, and we index and write out to both HDFS and also into something like Solar or Elasticsearch for that real-time dashboarding, real-time access and search side of things. And then there's a whole bunch of interesting stuff we can do on the back end of this. So we actually can do model as a service, so that's running machine learning models within that data stream as well. So adding full machine learning to the whole cybersecurity world. We can also import PCAP forensics as well, so you can look at individual chunks of PCAP within the Metron platform. So who's using it today? Well, one of the flagship cases is an organization called Telstra. They're a telecommunications and cybersecurity provider in Asia Pacific, and they spoke at our DataWorks Summit earlier on this year. They actually built 2 complete brand new security operations centers and deployed complete Apache Metron within 8 months, and that was fully deployed, completely sunsetting all of their previous legacy kit. There's some interesting sort of information from that. They were dealing, in October last year, they were dealing with 13 billion events per month, and they were growing at about 30% every month. Capital One have been on this journey for a while. This is a screen capture from back when it was called the Hadoop Summit back in 2016. So they were back then talking about 1 billion events a day, and that was only their internal corporate network. That's not counting the external stuff they're doing. If now you search Apache Metron, Capital One, and Purple Rain, you'll see the latest iteration of what they're doing right now. QSite IT, fairly recently acquired by KPN, have also spoke at our DataWorks Summit, and again, some of the things that they valued was the ability, this is 100% open source, so the ability to extend and add functionality that they cared about and participate in the wider community. So it's not just, customers that I work with that are using this. There's a wider ecosystem of people actually now providing, if you like, Metron as a plug-in appliance. So organization called PSSC Labs, teaming up to Crunch Data and Crush Hackers. Presumably they drop the rack on them. I'm not quite sure how that works. But the whole idea here is making this tech really, really easy to consume. So some other places that are using this, a large automotive manufacturer did an initial pilot project with us not too long ago, and they were looking at this with using raw PCAP data and autonomous cars. And the goal there was to satisfy over 1.1 million events per second, which we achieved on some fairly crusty old hardware. We knew it was crusty old hardware because through the process of the POC, we burnt out several of the RAID controllers and the cards. So yeah, I would thoroughly recommend using new hardware if you're going to go down this route, or deploy in the cloud as Telstra do. Major US telco actually did some back-to-back testing between their traditional SIEM platform and Apache Metron. They found that they got between 29 and 30 times faster response from their Metron platform than their traditional SIEM, which they are now sunsetting. The other interesting thing is that Metron actually returned more results when being fed the same data. When they dug into this, they realized that's because their traditional SIEM platform was just dropping events when it peaked and it couldn't handle it. It wasn't even telling them that it couldn't handle it. It just silently kind of left those few events laying on the floor. Multiple defense departments are using this around the world. Multiple governments are looking at using this for even complete countrywide coverage, which is just a staggering amount of data. So deploying Apache Metron is a bit of a journey. People often start off with some sort of proof of concept or proof of value. They come up with a couple of use cases that maybe they can't already do today. Something that they're interested in that really showcases the power of big data. Once they've gone past that stage, they usually start to understand, well, how can we go through the process of migrating away from our existing platform? So this is a project that is going to be kicking off early next year that I did some high-level solution design work for. So they've got the traditional ArcSight platform, they've got data coming in from their various security assets, and they've got some HDP already and a bit of NiFi used for other BI-related uses. They've also got a whole bunch of Active Directory, asset databases, HR stuff, threat intel stuff. So the first step is to actually get some of the core HCP or Apache Metron components plugged in around it. So start to add Kafka, add Storm, add Solar, get the data flowing through, get some basic dashboards and the Investigator UI up and running. Start to use Spark for some of that historical analysis. One of the amusing facts about a lot of the traditional vendors is they say, yeah, so we'll deploy this today, don't really expect anything for about 6 to 12 months. because the platform's still learning. Well, that's just great. 6 to 12 months of just hoping we're okay. One of the nice things about the majority of organizations is they do actually have some data that they could begin batch loading very fast into the platform. And we can take this and we can actually use Apache Spark to batch run over that data and generate profiles very quickly, in minutes or hours, over that historical data. So this gives you the ability to actually fast track your understanding of what's happening and baselining all those profiles very quickly. Once you've gone through that first state, you're then looking at adding a few extra pieces. So start to bring in some of that enrichment data in. Start to bring more data sources in that you couldn't load into the previous platform. Also start to look at adding more profiles into the equation. And then finally, you can look at things like dealing with NetFlow and PCAP data, even sunsetting the data going out into your legacy platform and pushing more data into the Metron platform, and even having some sort of automated response for critical events. There's actually an organization I work with who the majority of their users access their core systems through virtual desktop infrastructure, VDI. The interesting thing about this is when they are very certain that a virtual desktop has been compromised, there is a fully automated process that just goes out and rebuilds that virtual desktop regardless of what the user is doing at any point in time. Slight interesting thing about this is because the events are fully correlated with a lot of additional information like AD and HR information, they also know the person's level in the organization. If the person who's clicked on that cat picture and had his machine compromised is above a certain level in the organization, they get a courtesy call first. Hi, just to let you know, we saw you click on that cat pic, your machine's now infected, we're going to be rebuilding it, thank you very much. So another nice way of making sure that you're using the data effectively and not upsetting people too much. So when we're talking about Metron, often we'll be talking about, well, this all sounds great, but how do you size something like this, something so complex? You know, you're using HDFS and Ranger and HBase and Storm and Kafka and all the toys in the toy box. Well, it's actually relatively simple to start getting some metrics to understand what it might look like. So first of all, try to understand how many events per second you're dealing with across the different data sources. Try and get averages and peaks. Try and get an average size of each individual event. It still surprises me today how many organizations have actually no idea what these metrics are. They just don't know. We have devices, they squirt data around our network, we really don't know how much data. So it's interesting when they actually start digging into it, they actually realize how much data they have on this that they're mostly unable to utilize. So what does your retention time want to be for the different, as I call layers, the hot, warm and cold layers? We'll see a bit more about those later. How many enrichments are you adding to each and every event? Because each enrichment just increases the size of that event ever so slightly. And how are you going to size your nodes between the hot, the warm and the cold layers? I/O considerations, so typically you want to use SSDs in the hot layer because that's the index layer, the Solar or Elasticsearch. Are you going to be looking at PCAP? If you are, you probably want to be streaming that straight into the cold layer. So this platform grows sort of initially. You start off with maybe the first 3 months, you deploy a hot and a warm layer. As you grow to 12 months, you'd probably cap that hot layer at about 3 months, somewhere between 1 and 3 months of data. The warm layer would grow through to that 12 months. And then you can start adding cold data on top of that. And in fact, that cold layer then can continue to expand. And data just rolls from warm through to cold as your attention time increases. So the glory of big data, you can effectively retain this data for as long as you're allowed to by regulatory purposes, or as long as you like, or as long as your budget will allow. So what I'd like to show is some of the things that other organizations are also doing with Metron. So we've got a number of partners that are developing some pretty cool stuff with Metron. And let me show you this. So this is built on the underlying Metron platform. This particular dashboard is something called Elysium. It comes from an organization called SS Tech. And you can think of this as a plug-in layer on top. So they use the same Metron underlying platform. They use the same analytics. And all they're doing is providing... let's see if this is actually... Okay. And so this is using the same Metron underlying streaming engine and going through to understand the behavior of certain users. Again, it's enriched all this data so it knows the person's level in the organization. The more senior the person that's been phished or attacked or compromised, the more risky they are. Also an understanding of what their web sort of profile is, what their traffic profile is, the sites that they're visiting. So you can do very simple things like just adding top 1 million websites and seeing who is visiting sites outside that top 1 million. Things like that. Very easy to do within the real-time stream here. So from that you get the ability to develop 360 user views, not just a view of what they're doing within one silo, but across all the different silos. So login attempts you can see there, the individual events that make this happen, and you can even, once you detect something that you actually care about, you can even raise a ticket or some sort of escalation case through the platform as well. So that is the core of what I have to share with you so far, but I'm interested in your questions. So remember, the first really good question gets a pen and a notebook, although you'll have to come down. Okay, let's see. Let's see if you qualify. Go for it.
Thank you for the talk. I have a question about deployment.
Yeah.
So what are the main roadblockers that you have encountered? Is it people, technology, or any other limitations?
Oh, that's a great question. So, well done, you win. People, technology. The greatest blockers are usually actually getting the right people to understand the power of big data in the first place in the cybersecurity context. Cybersecurity people are notably conservative. They've been dealing with black box solutions forever, and they're very much used to this whole situation where, oh, my such and such doesn't feel secure, so I'll buy this black box appliance, plug it in, and everything will be fine again. And so in many cases, actually convincing them that perhaps you need to see a view across all of those black boxes could be more valuable to you. So there's definitely a bit of enlightenment that comes first of all. After that, I would say it's just getting the data in the right place. In the majority of cases, organizations don't really have a great way of moving data around. So adding something like NiFi into the mix kind of helps to fix that. And then the third thing is really often getting a big data team, if they have one already, linked up with the cybersecurity team, can in some organizations be a little bit frictious, because in some cases they've been kind of operating completely isolated before. So sometimes we actually end up making those introductions, which is kind of weird within an organization, but it does happen. And so I would say those are probably the key things. So getting organizations that are more used to black boxes to deal with open infrastructure and open architectures and open source technologies. So yeah, I would say those are some of the blockers that we often have to overcome. But the good news is that they are all easy to overcome given a bit of time. Thank you. Yeah, go ahead.
Hi. So I had a question. Is this actually improving the situation, or is analysis profiling basically just allowing us to stay in the same place because the attacks are also improving and increasing in numbers, and without it we would just be getting worse?
Okay, so I think it is improving the situation. I would say there are a number of reasons I think that. There's a notebook for you. So one of the things is that in many cases, organizations are finally starting to work together. Apache Metron graduated to top-level project status. Now, within Apache, that's kind of a big deal. It means that there are multiple organizations now contributing together to the core Apache codebase. But beyond that, this means there are multiple organizations talking about cybersecurity in an open way. So what we're looking forward towards is the ability to do things like share profiles amongst organizations. I mean, if you look at what's happening on the other side of the fence, attackers are sharing data all the time. They share toolkits, they share tools, they share exploits. Organizations aren't really very good at sharing that kind of approach. So we are hoping, and we've seen some evidence that this is taking place, that the open source and the community and the collaborative approach is actually improving things on the open source side and across organizations. The other thing is that we're enabling all of this to happen in real time. So in the majority of cases, organizations just find out something's happened too late. So even when they do find out, they can't sort of mitigate it. They certainly can't predict anything, which again, given what we're able to do, it's a big data platform underneath. So all of the machine learning and analytics that you're familiar with in big data world, you can apply to cybersecurity. So I think we are making it better step by step. Honestly, there's still plenty of time and there's still plenty of work to do here, but I think we are slowly getting ourselves into a better state.
Okay, and now let's move on to Slido questions.
Okay, so this means switching here so I can not stare at the screen. Let's see. Yeah, but then I'm kind of... So, let's go here. So, the latest big data use case... I think I've talked about a number of the use cases that I've mentioned throughout the session. So, hopefully that's already been answered. So, next one. Let's assume we already have categorized users' computers by their normal behavior activity. How you define include normal change in users' activity? So, in many cases, what you'll do with the profiler is if there is a change and that change is normal. So, for example, a user changes shift pattern is something sort of that happens on a fairly regular basis. You just rebaseline at that point, and you say you include that new data as normal. And again, it's relatively easy because this is all just run as a quick Spark job in the background. So rebaselining is fairly simple within the platform. There's no kind of we need to kind of let it learn this person's new shift pattern over a period of months. Okay, so next question. Any advantages of Metron over a set of AWS tools, GuardDuty, CloudWatch, etc. for AWS cloud infrastructure? Yes, absolutely. And the main one I would say is portability and lack of lock-in. There's absolutely nothing wrong with those tools, and if you are 100% all in AWS, then maybe that's good enough for you. Very few organizations are all in on any given cloud provider, and most organizations that are already very heavily cloud focused are now trying to think about what their multi-cloud strategy is. Very few organizations see their future as being just tied into one cloud provider, because that's just the mother of all lock-ins all over again. And one of the things about open technologies is about trying to reduce the amount of lock-in that you get tied into. So there's nothing wrong with those tools at all. If you're all in on AWS and you foresee you always will be all in on AWS, then go for it. But if you're interested in a more open approach, and honestly an approach that is not just driven by one organization but driven by a community, then I would say Apache Metron is worth investigating.
So we are out of time. So let's give it up for Dave Russell once again.
Thanks everybody.
Thank you.